But we'll continue our discussion next week on FAFSA, finishing that up. And then we'll start looking at colleges, or we'll look at grants, scholarships, and then we'll finish it up by looking at all the different types of schools. So we'll start with some of the Cal State system, San Bernardino, Fullerton, Long Beach, Dominguez Hills, Channel Islands if I need to. And then we'll move on to the UCs, and then we'll hit up the out-of-state colleges if I need to. So we'll talk about all those, how much they are, what's the majors, how they're defined, and everything. Decreasing function, going down all the way to 0. So there's going to be decrease, and we're going to have 2 of them. So it's going to go from -4, comma 0. And then we're going to have an increase from 0 to 2. And then we're going to have a decreasing again on our last interval from 2 to 4. What's up?
For the decrease, why is it -4 to 0, not -4 to 3, and then 0 to -2?
In this case, we want to look at the domain value inputs. So this is going to give me -4 to 0. Like if we're going to squish it down, so this is our domain for its decreasing for our first one. And then we're going to look at where it's increasing again. So it goes to 0 to 2 for these values. And then we're going to see our last decreasing from 2 to 4. So it's going to kind of be, so just squish them down again, just how we would do the domain of anything. So if we're just looking at increasing and decreasing left to right. Yes. In this case, it should have been, this one should have been open parentheses, because the value in which is decreasing by has an open circle. So this is open circle to this part, closed circle. Right, so we can define it as not inclusive. Right. I'm not going to be too stickler about that. Okay. Looking at whether our function is increasing or decreasing, we're going to look at the rate of change function, f of b minus f of a, all over b minus a. When we plug in our values, this is going to be f of 10 minus f of 0 all over 10 minus 0. When you plug in your first value, 10 to the third power is 1,000. 1,000 minus 400 is 600. So I'm just going to do this in my head just to save some space and time. F of 0, anything times 0 is 0. 0 minus 0 is just 0. And then 10 minus 0 is just 0. So when you plug those in, we're going to get 600 over 10. The 600? From this part right here, if we were to work this problem out, this would have been 10 to the third power minus 4 times 10 squared. We would have got 1,000 minus 400, or 600. Plug it into the function itself. Yep, just plug them into the function. Plug in f of 10. In this case, f is given to us by the function this. You okay? So we're just plugging in. Right, f of 0, 0 times 0, 0 minus 0 is still 0. So I just kind of cut the corners on that one really bad. So no worries. This is going to give me 60. This is positive, so do I have increasing or decreasing? Increase. There's an increasing portion on the interval from 0 to 10. If we're looking at the next bit of this, we want to be able to describe the function transformation. Do we know what type of function this is? Do we? No, we have no idea what it is. It could be a quadratic, it could be a square root, it could be anything. We don't even know. So we're just asking you to provide the transformation of this. The first part that I want to be able to look at from left to right is our first one here. The negative tells me it's going to be what? X-axis reflection. And then I'm going to look at the 1/2. So on the outside of my f of x, it's between 0 and 1. So there's going to be a vertical shrink by 1/2. Then we're going to go ahead and look at the internal portion, plus 3 of my f of x. We're going to be given a shift left. We'll just make it really obsolete. Left by what? Always do the opposite on the inside of our function. And then our last one is tell me this minus 2 is going to be what? Down. Shift down. Almost spelled it wrong. Almost spelled shift wrong. And almost missed the F. That would have been bad. Not bad. We don't want to do that down. Okay. Yes. That doesn't matter the way you write it. Some of you probably did a shift left by 3, down by -2, an x-axis reflection, reducing by half. Whatever way works. It will probably describe like what the shifts are for you. If you have a number on the outside of it that's being multiplied by the function, it's considered a vertical or vertical a stretch or a shrink. In this case, because it's between a half, think of it like a dilation. It's half the size of it is. So it's going to get smaller towards the line. Whole number or greater than 1 will be a stretch. It's getting larger by the factor. If it's on the inside, this is why I'm really not going to give you one on the inside, because it's the exact opposite. If we had a half on the inside, it'd be now a horizontal stretch. It's getting wider. If this was a whole number, it'd be a horizontal shrink. So it's counterintuitive to the inside of this. This is how the inside value is plus 3. You go to the left instead of right. This is the exact opposite. So don't worry about the inside, just worry about the outside. Yeah. So we'll go over it more. We're going to do some problems on those, so don't freak out. Okay, do me a favor. Let's give you guys your answer key to your homework, so please check this out. Those are all done for you. So please check it. Please check your answers. So you could tell me definitively what the shrinkage is done by. So yeah, I do want you to tell me. Was the email sent out? Did you guys check for me? Was it done? Okay. Okay, I'll resend it out. I'll resend it out at lunch today so you can meet you guys. I definitely want to start applying for FAFSA for you guys. October 1st is an early deadline, so if you have any colleges to pick from, I'll send out that list again of what you need. I think you need W-2s from your parents, your social security number, and just small information of your closed bank statements that you can submit. So definitely want to have this. Yes.
When the negative's on the outside, or the negative, and it reflects x.
X.
Okay, and then on the inside.
Yeah, like number 5, since it's on the inside, it's going to be on the Y. It's on the Y. Absolutely. Questions at all? Going once? Questions all going once?
So.
The reflection will be negative and then it's positive.
It's the same. It's the same. Yeah. So if you're looking at like number 4, this is just a vertical shrink by a half. If there was a negative a half, it would be a reflection and a vertical shrink. Yeah. Okay. Here we go. The handout that you guys have in front of you, let's pull it out. This is not going to take us that long to do, but I want to make sure we cover it all. This is what you guys have in front of you. Now, what we're essentially looking at is quadratics. We're going to look at maximum and minimums. Maximum and minimums. The handout is over there. I'm a little cold, so I'm going to turn off the AC. I'm sorry. You guys have the handout. All I really want you guys to do is go ahead and graph those 2 functions down below. You guys have those 2 graphs right here. If the a value is less than 0, or sorry, greater than 0, the function value is going to have a minimum. If the a is less than 0, you're going to have a maximum. Underneath standard form, what I want you guys to write is our equation in standard form. I'll tell you right now. You're going to graph this right here with your vertex being a minimum. This is a min. And then you're going to graph this one to the right, which is you're going to have this one at your max. We are looking at completing the square. There's another version to do it. So we're going to look at two ways of finding a minimum and maximum value. A minimum value is telling us the lowest value it can take on of a quadratic. And it's usually given to us by our vertex. So we've seen a lot of these. We should have been able to get vertexes last year. We should know how to graph. I'm assuming you guys know how to graph a quadratic. So we're going to look at graphing some of these, finding domain and range and stuff. Okay. But what we're looking at for a maximum is the biggest value that it takes on for a quadratic. And we want to be able to look at how we're going to define those. So if a is greater than 0, we're going to have a minimum. A is less than 0, we're going to have a max. Okay. The first way we're going to do this is by converting it into our standard form. Our standard form is going to tell us whether a is larger than 0 or less than 0, and that's going to help us determine those values. Okay, that's all we got to do. That's all we got to do. You guys don't have to copy down everything. Just trying to give you guys a basic so we can move on, do some problems. It's not too tricky today. We are going to be doing 2 word problems. One I'm going to give you guys for homework because you will have one tomorrow. If you guys have calculators or calculators on your cell phone, those will be assistive today as well. So those will be very, very helpful for you. I recommend you guys use parentheses when you're plugging values in again, but we'll cover that in a little bit. Can we move on? Okay, here we go. Are you okay? Okay. Looking at our first one here, we're going to kind of just jump right into it. Standard form of the equation, we're also going to graph it to find information about it. Domain and range, is it a function, is it continuous? Just as we did before. Looking up here, it tells us to write f in standard form. Basically, we're going to try to complete the square on it. So what we're going to do first, this is one way of doing it. Do you have to do it this way? No. So if you're not comfortable with completing the square, okay, on the quiz tomorrow, if I ask you to do this, you can use whatever method. The second method is what students have been preferring because it's like, oh, I can just make sense of that easy. Whatever works. Looking this down, so we're just going to do one of them in our standard form. We're going to move on to our completing the square for our second one. The last bit, we're going to show you the different versions. So what I'm going to do first is I'm going to go ahead and bring down my equation. 2x squared minus 12x plus 23. I'm going to set that equal to 0 because I'm going to complete the square with it. Just as we did before in our last test, we should be able to do this. Okay, they will be able to look nice, not like the test. Okay, I understand. Leave me alone. Okay, I'm going to move over my 23 and leaving a blank on one side. Get that minus 23. We got to complete the square. Okay, first thing we got to be able to do is pull out the GCF. Greatest common factor of this is going to be 2 minus 6x plus something is equal to negative 23. How do I find the GCF term? Or sorry, no, the CTS term. Negative 6, right? Negative 6 divided by 2 squared is going to be that completing the square term, which is going to be what? 9. What I do to one side at 9, what should I add to the other? Why 18? Because we got the whole number up in front. So essentially we have to multiply these two that we're adding in. So 2 times 9, we got to add 18 to the other side. So we're going to add 18 here. And again, if you don't like this method, you don't have to choose this method. Okay, I'm not going to ask you guys to. To me, I like it just because I understand completing the square. But there's another method you can do always. Okay, we're going to simplify this to write this as a complete factor. X minus 3 squared. Negative 23 plus 18 is going to be negative 5. When I bring everything over, this is now going to be my equation. Plus 5 here. This is the standard form of that original equation. Can someone tell me the vertex of this? Positive 3, 5. What is my A value?
2.
Since A is 2, do we have a minimum or maximum? A is greater than 0, so we have a minimum. So I'm going to look for these two on tomorrow's quiz. Hint, hint. So we have a minimum at 3, 5. So let's graph this. Our vertex point is going to go over 3, up 5. Because my value is being scaled by 2, my outer points is going to go over 1, up 2. Like that. That's all I want to see. Minimum value that this function will take on is going to be 5. The lowest point that that value will take on is pretty much your vertex. Okay, that's all we wanted to be able to see here. Is this hard to do?
No.
No. Yes, kind of. You just don't like completing the square, right? Is that what I'm assuming? If you don't like completing the square, it's understandable. Okay, I'm going to show you different versions to do. Be understandable. Yes. I'm going to ask for 3 dots. I'm going to ask for 3 dots. Yes. Yep, always have 3 dots. Always have those 3 dots. Okay, here we go. Let's look at the next part of this. This is a reduced version of it. All I want you guys to do is just copy down the graphs because everything else is you already have. So you guys have these, so just copy down those 2 graphs. Basically, it's telling you that you have a maximum when A is greater than 0, or a minimum when A is greater than 0, a maximum when A is less than 0. That's all what I want you guys to write down for that. And it pretty much tells you the quadratic function for those. We're going to look at a minimum value one more time to look at completing the square just one last time so you at least have 2 examples if you choose to do it that way. And then we're going to look at the other version. If we did not like completing the square before, if we did not like factoring, what was another method to find our vertex? What was it always go to that you can? What was it always go to that we can use? The quadratic equation. The other formula I'm going to show you is just like the quadratic equation. It's going to be your go-to when in doubt. You hate finding the completing the square or factor. You're going to be always able to use that. I'm going to show it for the last couple of problems because most kids prefer it, actually. Most people don't like doing the completing the square because there's so many different ways you can mess that up. And this one, if you're really good with plugging in, you're going to be good. That's pretty much it. Okay. So let's look at our next example here. Here we go. We're going to complete the square one more time. We're going to find a graph. We're going to evaluate it. And then we're going to ask a little bit more about this before we kind of go into more of the solving part. So it tells us 5x squared minus 30x plus 49. So I'm going to write this down. 5x squared minus 30x plus 49. I'm going to set it equal to 0 because I'm going to complete the square first. Subtracting out 49. You guys like when I show all my steps? It helps out. My apologies because I didn't do that in the beginning. Okay. I subtracted out 49. I know how to add something to both sides because I'm adding in something into the equation. We're going to. We need to still pull out the GCF. That's our next step. We're going to pull out the GCF of this. We're going to get 5x squared minus 6x plus something is equal to negative 49 plus something, because we got to add that in. What is the CTS for it? Completing the square term. 9, how'd you get 9?
Negative 6 divided by 2.
Negative 6 divided by 2 is 3. Negative 3 squared is 9. So what should I add to the other side? 45. Beautiful. You guys are understanding that. Again, if you don't like this method, you don't have to use this method. I'm just showing you. Don't freak out. We're going to complete the square term. We're going to get 5x minus 3. We're going to factor that nicely. Is equal to negative, what is that, 4, right? We're going to bring everything over. And it's going to tell us our equation for our quadratic here. Boom. Let's talk about this. Do we have a minimum or maximum?
Minimum.
Why minimum?
Because A is greater than 0.
A is greater than 0. What's our A value? 5. So when A is greater than 0, A is greater than 0, 5 is greater than 0, we're going to have a minimum value. What is my vertex? 3, 4. So we're going to have a minimum value at 3, 4. So it should be facing upward because we have a positive value. We're going to go over 3, up 4 is our first one here. What is our factor? Our A is 5, so we're going to go over 1 and up 1, 2, 3, 4, 5. So our factor is going to go up 5. It's going to be a stretch graph, right? It's going to be our stretch graph. It's going to look very slim. Okay? It'll look very slim. I know it's going to kind of fill into the other one. Okay? Yes. Yep, because the A value. Why did we go up on 3 the last one? Because the A value was what? 2, or we went up 2. Sorry, we went up 2. So that's all you got to do. Go over 1, up 2, over 1, up 2. If the factor is A. If it was 1, how would we go up? Over 1, up 1. If it was 6, we would go over 1, up. If it was negative, we would go over 1, down.
6.
That's how you graph quadratics, honestly. And 5 over 1 could always be written as 5. A fraction is done a little bit different. You're still going to always go over 1. If it was a fraction like a half, let's say A was a fraction, let's say a half, you would still go over 1, down a half. So that's all you got to do. Cool? Okay. So this is one way we could do it. Now before we kind of move on, can we discuss this? What is our domain? Just really quick for this. Just kind of hit. What is it? Good. Our range? 4. Positive infinity. Continuous or discontinuous?
Continuous.
How do we know it's continuous?
There's no jump.
There's no jump. We could draw it from left to right without picking up our paper. Is it a function, yes or no?
No, yes.
Function. Why is it a function? Pencil test passes through every single point. I might give you one tomorrow. I'm just saying. Just saying. I might just ask. Question? There was a question back here?
So if you ever do go over 1 and goes down, does that mean it's going to be max?
That's going to be max. Yep. If we're ever given a value of A, in which is less than 0, this will take on a maximum value, and you're still going to go over 1, down how many you're going down for your A value. In this case, because A is positive, you're just going over 1, 1, 2, 3, 4, 5. That's it. Yes?
How important is it putting the brackets and parentheses?
For the brackets and parentheses is important for this one, in this case, because we know it's continuous. I'm not too stressful about it as long as you have your interval notation correct. I think Miss Nguyen, who teaches calculus, and Mr. Oberhauser, who teaches calculus, you have to be on point with those being bracket and parentheses. So yes, I'm going to stress it, but no, I'm not going to stress it at the same time. So, we're going to keep that in mind. We'll just keep that in mind as we do things. Unless I tell you make sure your brackets are good, I'm okay with that. Because some of you guys write some of you guys will write this. And it's like, I did a bracket, but it's parentheses. I'm like, it's like one of these things that you get for like a true false. Someone would write that. But it's true false. It's true. I wrote true. I'm sorry. Like, come on. So it's like the same thing. So I'm not really worried about that. Okay. So yes, it works. That's why I put true, false, circle one. So you can't get out of that. You can't do like double it. So here we go. This is the next part. This is the one that will always work. This is a good one to use. We're going to be using it for our word problem. So I'm going to use this for the rest of the time. Now we can use completing the square. You don't have to. This will work all the time. One thing that you guys are going to see here is, do me a favor, I'll highlight or circle this. Your x value for your vertex is going to be negative b over 2a. Your x value that we're going to solve for is going to be our first value in here. The second thing we're going to look at, your y value, is when you plug it back in. When you plug that x value back in. If your a value is greater than 0, it's still a minimum. If your a value is less than 0, it's going to be a maximum. So we're going to look at this again. This is not too difficult because we can still determine. We're going to determine whether it's a min or max first. We're going to find our x, and then we're going to plug it back in. Yes? A was 0, it would be a linear equation. Or even a constant value. It'd just be, think about it. If we plug in 0 for these, you just get left with -5. It's just a straight line. There is no max, there is no min. It's just a value. So I will never give you when A is equal to 0 because it doesn't help us out. So don't worry about that. It will never be 0. Looking at these two problems, it says find the max or min value of each quadratic function. First thing I want you guys to do is tell me if it's a max or a min. That's the easiest part to tell them this because they always take on ax plus b, ax plus, ax squared plus bx plus c. One thing I always know about a, I can always add a 0 in here. Doesn't change anything up with that, right? Ax plus by equals, or ax squared plus bx plus c. What is my a for my first one? 1. Since a is equal to 1, is that greater than 0 or less than 0? So do I have a max or min?
Min.
It's a min. First out, we have a min. Done. That's half of your question. Good job. It's half of your points right there. Look at you go. Now, in order for us to figure this out, we got to find our vertex point. If we find our vertex point, we're going to find where the min exists, just as we did before. What we're going to use is the following equation. We're going to use x would be equal to -b over 2a. We're going to use that equation by plugging in our values, and which is represented here. What is my b value for my first one? 4, so I'm going to write -4. I'm going to put parentheses around my plugging in terms. It helps you differentiate those so you know that you're doing the correct integer operations. What's my a value? 1. We're going to simplify this out, get -4 over 2, or just -2. So to start this up, our vertex for this first point is going to be at -2. That's our first point. At -2 is our vertex is going to start to begin with. Now we got to figure out the y output for this. So what we're going to do is we're going to take this -2 now, and we're going to plug it back into f of x. So it's going to be f of -2. If we plug it in, it's going to give me an output value. That's what I'm looking for. So we're going to exactly do that. I'm going to do -2 squared plus 4 times -2 plus 0. 0 doesn't happen, so I don't need to add it. Let's simplify this out. I'm going to write it up so the people in the back can see a little bit better. -2 squared is what? 4 plus -8 gives me what? My output is -4. We're done. That's it. How many people like it this way compared to the other way? People prefer this. Yes? Yes, you can. Yes, if you like it. That's why I showed you completed square in the beginning. Now, when we get to the word problems, you're going to want to use this form. Because I'm going to give you stuff that's going to give you decimals. It's going to be more trickier. Could you still use it? Yeah, but you got to be really careful about completing your squared terms. You got to make sure that you're doing everything right. And sometimes because you're looking at, factoring decimals, might be confusing for them. So whichever way works for you. Absolutely, whatever way works for you. For number 2, let's look at number 2 here. Number 2, we have it in our form. Let's check it out. Whether we have a min or a max. What do we have? Why do we have a max? A is equal to -2. A is less than 0, so therefore we have a max. Good for you. Yes?
So what would the answer be for A? Would be
Minimum value at point -2, -4.
okay.
That's it. That's it. It'll pretty much tell me where's your minimum value. It says find the minimum or maximum value of the quadratic. We have a minimum value at -2, -4. Right? That's it. So we have a maximum value. We got to solve for our x, so we're going to use x is equal to -b over 2a. We're going to plug our values in. -4 over 2 times -2. What does that give me? Which is 1. First value here, 1. What should I do next? Plug it in. We're going to plug it into our g function now. This is the same thing as plugging into the f function, just We're just using G for the name. We're going to plug this in. -2 times 1 squared plus 4 times 1 minus 5. I'm going to simplify this all one down. -2 plus 4 minus 5. Or we're going to get, what is this, 2 minus 5 or -3. Function has a maximum value at 1 comma -3. Negative 2 minus 5?
Oh, you square the one.
Yeah, 1 squared. 1 squared is 1. 1 times -2 is -2. You can plug this in directly into your calculator. Do you need to show this step? I'm okay. If you show me this part and you give me the answer, I'm okay with that. I think you guys can operate calculators pretty well. So I'm okay with you showing me that. I'm just showing my steps in case for those that want to see all the work. So I'm okay with that. Does this make sense? Pretty easy. And we use these same type of problems when we're solving for quadratics, when we're solving word problems. So let's look at these final stuff here. Let's look at, we're at 30, 60 minutes left. Should take about another 5 minutes on this, 5-10 minutes hopefully. Looking at the problems down below. These are what we're going to get here. So we're going to check these ones out. We're going to check these ones out. So you guys have these ones. Is there a method that you prefer me using? Do you want me to do one completing the square or one just the formula? One of each? One of each? So the left one, I'm going to do completing the square. The one to the right, I'll do the plugging in. Are we okay with that? Okay. Let's look at completing the square for our first one. I'm going to go ahead and do this one here. I'm going to rewrite it down below. So first of all, before we even begin this, what's the first thing we got to tell? What's the easiest thing for us to do? Min or max, right? It tells us min or max. Now, without writing anything out, can we determine if this is a min or a maximum? What do we have? Max. Why do we know it's a max? Max is less than 0, so it's going to be a max. What about the other one? Max as well. A is less than 0, so there's also going to be a max. So we'll just get those out of the way. We don't have to worry about them. We have a maximum value at those values. So we have maximum values. That means the functions are facing downward. So we're going to look for our maximum value. So I'm going to rewrite this. I'm going to go -x squared plus 6x minus 5. I'm going to go ahead and add 5 to both sides, leaving me a little space here on both sides. I got to complete the square on this one. Let's pull up the greatest common factor because we have to deal with this negative right now, right? So we're going to pull out that negative. So let's pull out that negative. Minus 3x plus something. Oh, I'm sorry, because I'm already thinking outside the box. I was thinking I was pulling the 2 out. 2x. That would need to be positive, so it's going to be negative in here. Negatives outside these things are not fine. What's my CTS term? Nine? How much should I be adding in? This is, think about the negative on the outside of this. So it's being added 9 to this. So what should I do to the other side? Should I subtract or add 9? Are we okay with that? Okay. This case that we're going to get here, I think we're subtracting, guys. I think we got to subtract it. Nope, we're adding it. I'm just kidding. We're adding it. We're fine. Simplifying this out, we're going to get negative x minus 3 squared. I think this should be, we got to subtract this. It's always opposite. Sorry. Still be positive. This will be negative. This is going to give me -4. Sorry. We got to subtract it if the negative's on the outside. We got to do the opposite. So we got to subtract it from that side. Sorry. Bringing it over, negative x squared here. I'm sorry? I would prefer just the other version. I think the other version is better. This is me. Whatever method you want to do. I think the other method is easier for these type of problems, but that's just me. Yeah. Oh, absolutely. Oh, absolutely. Our vertex, what's our vertex for this? 3, positive 4. Vertex at 3, 4 for our value. Yes.
Wait, I thought we were adding.
Yeah, but we have to deal with that negative on the outside of it. And the problems that we did before, we added 9 to this because we deal with the value, a function value that's adding to it.
So wouldn't it be negative?
Negative 9.
Or aren't we, because if we're taking out a negative, then positive, negative.
We're fine with this. We're fine. I just don't worry about it. You're thinking about it too much.
What is your
I'm not going to give you a negative value. Don't worry about the negative value. Because in our problems that we've done before, when we've taken out the greatest common factor, we've added in something. But in this case, because we pull out a negative, we're actually subtracting something from it. We're subtracting the multiples of them. So we got to subtract it from both sides. Just trust me on that. I'm not going to give you something like that if I give you completing the square. But the other method would work. The other one on the right-hand side is going to be the other version. I'm going to use x is equal to negative b over 2a. What is my b for my first one? So negative times a negative 2 over 2 times a, which is negative a half. So I'm going to get 2 over negative 1 or just negative 2. What should I do with my value? Plugging it back into our equation. We're going to plug it back into my f function. F of negative 2 is going to give me negative a half times negative 2 squared minus 2 times negative 2 plus 6. Even though this might look crazy, should be easy. Negative 4 divided by 2. 2 plus 4. Oh, make a booby somewhere. Negative 2 plus 4 plus 6. Thank you. We're going to get 2 plus 6 or 8. That's it. Good stuff? That's why I prefer this version over because I think I like plugging in values. The negatives can always mess you up. So just reiterating on this one. So going back to what I just said for you, we don't consider this part, so I still have a negative outside of here, written, right? So if we're thinking about what this is actually doing, how much am I doing? What am I actually adding into this equation? If I distribute this negative to a positive 9 in here, what does it become? How much am I really adding to it? Negative 9, right? So because I'm adding negative 9 to this, I got to do negative 9 to this side. Does that make sense? Okay. I was trying to explain it better. I don't think I did a good job. Does that make more sense, guys? Okay. Here we go. Do me a favor. Flip this over to the back side. I want to cover one problem with you guys. This is a word problem. Please copy it on the phone. Copy that bad boy down. You can abbreviate it. Now, in the problem that's given here, don't freak out that it's a word problem and I don't know what it's asking for. What is this 40? What is this t squared? What is this equation giving me? Don't freak out. These are not that bad because we're going to follow the same methods we've been asking for. It tells us the height of a ball. Very welcome. The height of a ball. Sorry, the height of a ball, if thrown, is directly upward with a velocity of 40 feet per second. After t seconds, the equation is given by 40t squared minus 16t squared. What is the maximum height that the ball can take on? So what are we trying to find? A maximum for this. So we're just finding the maximum. This is represented by a quadratic, right? If I were to throw a ball up, it's going to go with the trajectory of a quadratic. Let's have a model some of these equations. We can model trajectories of rockets, trajectories of balls, trebuchets, the distance between points. Okay. Now, does a 40 second per feet per squared, does it help us out? Yeah, it could. Will it help us out now? No. One thing that I care about is that equation. So what I'm going to do here is we're going to go ahead and copy down this equation. Y is equal to 40t minus 16t squared. Now, is this in the ax squared plus bx plus c form? No. Let's rewrite it so that it is. I'm going to rewrite this. Rewrite to ax squared plus bx plus c. We're basically rewriting it to putting a polynomial in descending order. If I rewrote this, this would give me negative 16t squared plus 40t plus 0. So all I'm doing is I just rewrote it. Helps me better understand whether I have a min or a maximum. Now looking at this and do the same process. What do I have? Do I have a minimum or maximum? What's my A? It's a max because A is less than 0. Okay? Could you complete the square again? Absolutely. You can definitely complete the square. Do these two have common factors though? Do they? Not really. So the other version of this is why the best version to use with this is the formula. Okay? Now, we know we're going to have a maximum. It's going to hit a maximum value at a certain point. Let's find out what that max is going to be. We got to be able to plug this into our equation. X is equal to negative b over 2a. What is my b? Negative 40 over 2 times 16. We're going to get negative 40 over negative 32. Can someone give me the decimal representation of that? 1.25. So yes, we're dealing with decimals. It's okay. So this tells me my ball hits a maximum height after 1.25 seconds in the air. This is our first one. This is t. Okay, that's our time. So at t seconds, at 1.25, we're going to hit a max. What is that max? How do we determine that? Plug it back in. That's all we're going to do. Just as we did with the other problems, we're going to do the same exact thing. So we're going to take our value and we're going to plug it into the original equation for y. So we're going to get negative 16 times 1.25 squared plus 40 times 1.25. What'd you guys get for this? Did we get it? 75? Check it again. Negative 16 times 1.25 squared plus 40 times 1.25. What's the height of the ball that is reached? 25 feet. If I had to give you guys a diagram of what this looks like, we're going to have a guy standing down below here. He throws a ball up in the air and it comes back down. After 1.25 seconds, it's in the air hitting a maximum height of 25 feet. Does that make sense? Okay. Do me a favor, for the homework, cross out the following. Okay, at the top of it, it tells you the problems you're going to deal with. If you want to try extra problems and extra practice, I have answers to all these. Do me a favor, cross out 1B. 1B, you're not going to do up at the top. You're only going to do those ones that are at the top of your. So read the directions, please. Make sure. Cross out B and then cross out 6B. So you only really have 4 problems. And I want to give you one more to try out. We're going to discuss this. This is the one we're going to give you. Sales. A soft drink vendor at the popular beach analyzes his sales records. He finds out that if he sells X amount of cans, then one day the maximum profit is given by the following equation. At what price can he sell the cans, and at how much money will he make off that profit? What are we basically finding again? Maximum. What is our A in this case? Negative -0.001. What's our B? What's our C? There you go. There you go. Those are going to be the passes for those. Bye, guys. Have a good day.